4, 3, 2, 1. All right. Share the entire screen. All right, perfect. Well, hello everyone. Welcome to the 4th class in the Data Manipulation and Management, or SQL 101 class. This is joining and merging data. This is where we take disparate tables today and join them on either join or merge them on their commonalities between the tables or primary keys to combine your new data sets. This is really important when we start to really blend data and merge data and create those new insights that you can use in business. But that's what this class will be. I am the instructor, Jeremy Bergman, in Omaha Data Science Academy. Right. So how is this class structured? For hour 1, you're going to focus exclusively on SQL joins. And we'll see why here in a minute. This is when it becomes most important to really visualize the data. And there are a couple of different ways you can merge data on their common columns or primary or secondary keys or foreign keys. In hour 2, we'll do subqueries and unions. Subqueries are like the word says, they're queries within queries. So you can actually create a query and put it inside another query to get a unique result. And unions are where you're appending or merging data together. You have 2 tables with the same columns. You can put them together to do one long column, and we'll see where that's useful. And then hour 3, we'll spend a bit of time on this, joining and working on practicing on joining and merging data. We do have a homework assignment today that covers class 4 and class 3. And we'll do a lot of examples here to really get a feel and really start to picture how we're bringing data together in a relational database. All right, quick review of class 3 data storage. This is all about DDL, data definition language, and creating those structures that hold data. And then DML, which is data manipulation language. So once the data is in a table or not even in a table, you're inserting it into a table where you can update and delete data once it's already in table. What we will do at the end of class, we'll work on importing data in SQL and CSV files. I did put a little note in Slack today on processes that would help you import files, but we'll do that as part of the homework and exercises at the end of the day. So with that said, we'll try to get to that a little bit faster. I just hit a button. Hold on one second. Go back to slideshow. There we go. All right, class 4 objectives. This slide looks like a lot, but don't worry about it too much. It's really just an overview, and we'll dive deeper into what all this means pretty soon. So SQL joins combines rows from 2 or more tables based on a related column. So this is where in class 3 we talked about a primary key becomes important, because how you would join 2 tables together on common columns that have common values. And based on they call it here a related column. So think about like an employee ID in one table and an employee ID in another table.
Hey, Jeremy.
Maybe they have. Can everyone hear me?
No, we can't see the slideshow.
Oh, you can't see it? Okay. Let me make sure you can do that. I might have pressed something here that lost you. I lost you for a second, didn't I?
Just for a second.
Let's see. Present. Yeah, hit a key combination and it did something there. Try not to do that. Thanks for the heads up on that.
No problem.
Okay. Back to it. Can everybody see it now? Doing full screen. Class 4 objectives.
Yes,
Okay,
I can see
perfect.
it.
All right. So, yep. Awesome. So, class 4 objectives, SQL joins I was talking about, combines rows to form two or more tables. For rows from two or more tables, to create a new data set based on a related column. So, a related column I'm talking about is you have one table and another table. Maybe both of them have employee IDs in it. They have two different sets of information, but they both have employee ID. You can join those two together in different ways to form a new data set. And we'll go in depth the first hour on the different ways that you can join data. A union combines data from the result of two or more queries into a single result set. So that's where you're appending the two data sets. You have a top data set and then you have a bottom. You could actually do this multiple times, but sometimes it's useful to have one query and a second query that have common columns, and you're just copying and pasting them on top of each other. And then subqueries is that a query that is nested inside a select, insert, update, or delete statement, or inside another subquery. So you can create one query and then put it inside another query. And you can do this in a few different ways. It's not just related to selects. You can do this in inserts, updates, or deletes. So you could even put subqueries within subqueries and do this infinitely. I would recommend against that because it really starts to get hard to figure out what's going on after a while. But we'll see how subqueries can be very useful to use within other queries that you create in SQL. All right. So class 4 objectives is joining and merging data. So joining data, there are three main types of joins. You can do an inner join, an outer join, and a left join. This shows an example here of an inner join. So you notice you have an ID column here, ID column in your second table. You have common values, which gives you a new data set. It'll give you the columns in the first table plus the columns in the second table, wherever this matches. So that's an example of an inner join. We'll see a few more here in a minute. And merging and appending data, as I described, there are two ways to do it: a union and a union all. Basically, this one is a union where you have two queries with the same columns, and then you append them together to create one longer data set. So that's going to warm up for the rest of this class. And then also an example of a subquery. This is one type of subquery you can do. You can select you can have, you notice that this is a select inside of the from statement. So when you create a query, it will end up creating a table like this. And then you can utilize that table, or you can utilize that result just like a table in the from statement. And then you have the outer query, which you can take the results from that and select state and do a sum of friends and then group it by state. So this is a little walkthrough. This is what creates this is the subquery, or this is actually the Facebook table. This is all of it. This one is a subquery. And then you can select those fields to create your final table. And we'll dive. This is just still an overview, so we'll dive into this a little bit more in the second hour. Right. So in each lecture, we talk about what is the need for data manipulation. We've worked a lot on class 3 was adding, removing, and modifying data, and the extracting and storing data. We've worked a bit with that, with those different statements and then queries. Now we're starting to get into some exciting stuff here. So creating new data sets and combining disparate data sets. We can do that with joins and these new operations or new clauses that we're learning. And then we can perform common queries, aggregations, and joins to transform the data. So new ways to create and extract data and new ways to transform the data for oftentimes answer the question or get the data set that you need to perform other analysis. Right. So how do you combine data? So this is where you can use SQL joins. SQL joins can be done using where or join clauses. And after I talk about each one of these, we'll do an example. For now, the most common ones are going to be your inner join, your left join, and your full outer join. So let me describe these. So this is where it becomes important to visualize. So say we have a table A and a table B. This one is an inner join, and it joins on all of the records only where A and B match. So like that key that we had in the example a couple slides ago, it'll only keep the records where both of these match. So up here is the other common query. This is a left join. So what the left join does is that it keeps all of the records from table A, and then it also includes all of the records where table B matches. So in A, you'll include the whole table, and then you'll see examples of where B matches. And if B doesn't match, it just leaves all of these values null. And we'll see an example of that in the next slide. But it's a good way to see, where a match might be. I always use a customer example, and customer example could work here. So say A is all your customers, and B is all of like the invoices. There are going to be some customers who have invoices, and then some customers who don't. If it doesn't have any customer information, it'll just leave the B part of the record blank, and then it will actually give you the records for A, the invoices. Say they have 10 purchases, you'll see the whole record A with the 10 purchases. So explaining it a lot, but really getting our hands on the data will help the most. The other most common query here is the full outer join. This is where it keeps everything where A and B matches, and then it keeps everything where only A matches, and then where only B matches. So I'm not going to go too much in depth on this one because I have a better slide that will give a better example than I think of off the top of my head. But we'll go ahead and move on to the next slide. Perfect examples of when to use joins. So your inner join that we talked about is when you only want to see data. So say you're having deals that have matching invoice records. Say, say you're a broker, like, well, what do we want to do here? Say you will be creative. You sell houses, you're a realtor, and you've made a deal. You'll only match the records that have an invoice record, or you've made a sale on those, and maybe that invoice is like some commission. So you'll bring those together, you'll get only those records. A left outer join is when you want to sum the revenue for all sales, regardless of there being a matching product record. So on this one, say you want to keep all of the rights. Say I'll use the same example from the last one. So say you've done these deals, they're all in A, and then you sum all of the invoice records B, and then maybe some of these deals they don't have any invoice yet. That'll be okay because you'll still have all the deals from table A, but you'll see where you have deals and then where you have invoices and where you don't, which provides valuable information because you'll see the total amounts for those deals that do, and then you'll have blanks for those that don't, and those blanks may provide really good information. So with the right join, it's just the opposite. It's the opposite of a left join. You're just seeing where everything matches on A and keeping everything in B. This can really be rewrote as a left join with table B being A and A being B. And then you can do a full outer join. So say you want to do all of them that are matching like an inner join, but you want to keep all deals and then also all invoices. Maybe there's some invoices that don't match a deal for some reason. You'd still keep all of those in the data set. So it becomes valuable to see. Then you could also see where you don't have a match on deals, where they all match, and then where you don't have a match on invoices. This one will always create the biggest data set because it includes everything from tables, and then it'll include a record where both of these match. So that's a primer for using joins. Let's start to see examples of all of these. So an inner join, we saw this right there in the introduction for the class, but now we have some highlights here, and then it works through this and shows you how it brings it together. So just a general syntax, you still have your select, you have your from a table, and then you inner join, the keyword inner join on the second table. And then I almost always provide these aliases. You could call Facebook as A and LinkedIn as B to be able to match those Venn diagrams that we had before. But this is where you have an inner join where they all match on a key. So the Facebook and LinkedIn, they have a common key. It's both name. You can see how it works. It looks in table A, then it works across all of table B until it finds a match. Once it does find a match, it puts it in the table and creates a Facebook, or it creates a table with the Facebook columns and then the LinkedIn, or columns from the LinkedIn table. And notice this one on Jeff. So it doesn't find Jeff anywhere in the LinkedIn table, so it's not included in this final result. And one thing I want to do, if you have questions as we go, feel free to ask. I have Slack brought up on the other screen here, so feel free to ask questions. If something doesn't make sense, and I'll try to. Sometimes these are about conceptualizing and reframing it a little bit, so just let me know. All right. So here's an example we can practice. So an example of official languages. Oh, now we're doing the world.country table that we've used before. and then we're joining world.country language on a.code is equal to b.country code, which is a common key. And then we could even put another criteria in there. We could say just official languages. So let's go ahead and run this so we can really conceptually see what's going on here. I think it really helps to run one table first and then the second table first, and then understand how this is coming together. So go ahead and do that from examples PowerPoint. Go to lecture 4. These slide numbers won't be quite right because I updated some slides today, but this one is a query, lecture 4, slide 8. So let's do this. Let's run these two separately first. So let's just select star a dot star from world.country as A, and then select star from this second table. So remember, select star selects all the columns in a table. I think the second class, Melinda, you asked what these aliases were on the tables. Maybe it was you, where I'm calling you out because you're here in class. Somebody asked what the aliases were on each one of these tables, and you can use aliases just like you did with the columns. I always honestly like using like A and B or A1 and B1 because I think of it in those Venn diagrams. So A is your first table, whether you're doing an inner join or a left join, and then B is your second table. So I always often do these as A and B and try to make that as simple as possible. I'm going to run both of these so we can really see what's in each one of these tables. World.country. Oop, that's my, they're both returning the same result. Okay, so let's run this again so I can return the same, or I can return the result. Okay, much better. All right, so this query, the world.country, this is in country 4. You see you have your codes, which is going to be your key that you are going to relate the two tables together with, that common key. Then you have the names, regions, surface areas, year of independence, all sorts of information about the country. So the second one is we have that country code, that common key that we can match on. And then you have language, but then you have is official. So you'll see some of these countries, they'll name them, they have a few different languages, and they can have a couple of official languages, and then the percentage of people in the country who speak it, roughly. So you'd see like America would have a bunch, or Austria, and that's Arabic, English. People in Austria speak German. So we're going to narrow these down in this query to just is official, is true. So now you're really thinking, like, how do we bring these two query results or result sets together? And now we just have all the official languages by country code. And now we want to say, select name from table A, select the language from table B, which will be this column, from world.country, and then interjoining world.country language as B on their codes, your country codes, because that's a matching key, and then interjoin will give all the records where there's a direct match between A and B. And then where from the B table, it's the official language. That's really in just English what this query is saying out loud. And then we have a list of countries and their official languages. So yeah, in American Samoa, you can see it's both English and Samoan, which makes sense. You have a few of them in Canada, English and French and so forth. So is everybody online able to run that query and see where the results come from? If it seems like magic, it feels like it at first, but then when you start to do some of these and really visualize them, it starts to make more sense. I think we're good. Good, Melinda? I pick on Melinda since she's here in front of me. All right. So we'll move on to left joins. So left join is what I said. Here's the syntax. You have your select, your from table A, and then left joining a table B on a key. So if it looks very similar syntax-wise, it is. You're just giving it this different left join clause, telling SQL, we don't want to do an inner join between these two tables. We want to do a left join on these two tables. So remember the Venn diagram, it'll keep everything in the A table, the Facebook table, and then join it where it matches on the B table. So you can see here in the Facebook table, it's going to include in the results here, since we do a left join, we're going to get all the records from this table. And then all the records where it matches on A or there is no match on B. So we have a match on Matt. We have a match on Lisa. No match on Jeff, which will actually, for table B, leave you null values. So I can't find anything. So null is different than 0 because it says, instead of saying there's none, it says we can't find any values for it at all. And that might make sense, right? Because Jeff would be on Facebook and not LinkedIn. And then you're trying to get the number of friends. But if you don't have that information, you don't know what it is for Jeff. And it's not necessarily 0 because, maybe Jeff's profile exists. It just isn't in that table. All right. So let's go ahead and do an example here. All right. So here's a good one. So which countries do not speak English as a language? So this is where we're going to take the world.country table and we're going to left join world.country language on your key, the country code. And then we're going to limit B to just the language of English. So basically the set are really close. Oops, I hit a button there. So really close to the inner join that we had before, except for official language on the B table, we're going to choose language as English. Okay. So if we just take the B table, and this will be lecture 4, slide 10 in your examples PowerPoint. So this is English is equal to true. So go ahead and put this up there before we do the left join. Oop, it's not called is English, is there? What is this column called? Language is equal to English. That's silly of me. Okay. Oh, language is a keyword. Is a keyword in MySQL, so we put the tick marks on it. Okay. So if we run this, we get where English is a language spoken in that country. So a lot of different countries speak English. And then what this one will do, will keep all of the countries in the world, and then it will join on where you have a code, country code, and where that language is English. So let's see what happens here. So you have Aruba with English, and then in Afghanistan, they don't have one of the languages as English. So this is important to note too, right? It's like now you can see in that country, English isn't a spoken language. Or at least said more accurately, it says there's no information about English being spoken in that country. Then you go down in Netherlands and a lot of Pacific Islands, you have English spoken, obviously Australia. But you can really see where in that table, in the world country language table, where there's information about this country speaking English versus where there's no information. Because even in Brazil, I'm sure there are people there who speak English. That information is just not captured in the country language table. So keep that in mind. It's like it's not really a zero or doesn't exist. Null is like more of there's no information about it when you bring the table together. If that doesn't make if that description doesn't make sense, let me know. It's important to distinguish the difference between like null and null is like not having the information, and then none, which is zero. So no quantity because there's no information, and thus it's null. Okay. Feel free to continue to ask questions. Actually, we're cooking today. Here we're almost to all the examples of joins. Thought I'd end this after the first hour and let everyone take a break because joins in themselves there's quite a bit to take in. All right, so full outer join, we are going to see an example of this. So same syntax as you've seen before, you just are using the clause full outer join instead. So this should take all of the records here that match. Well, it should take all the records in A, and then it should give you where they match. And then it should give you also information just where LinkedIn matches. And then it adds that column at the bottom because for Lewis, there's no match in table A. So we'll keep this information and make a fifth row on B. I use full outer joins the most is when I'm trying to figure out what records from both tables match or don't match. And that can provide some important information. Oftentimes, it can be a data quality issue. So there's not a key for one table or the other, and then you have to see why there's not a common key between it. Where perhaps the two tables should match up, but for whatever reason they don't. But it could also provide really valuable information like Jeff is on Facebook but not LinkedIn, but then Lewis is on LinkedIn but not Facebook. Let's go ahead and see an example of this. Full outer join example. This one actually includes a union in it because this is another way of being able to do a full outer join. It's actually a combination of a left join and a right join. If you think about it this way, we haven't got the unions yet, but remember, unions are where you append the tables both on common columns. So if you think about this, this is a full outer join is the same as a left join in a union with a right join. So the left join will keep everything in table A, whether it matches or doesn't match. They'll keep everything in table B, whether it matches or doesn't match. And we haven't covered union yet, but what will happen is that'll bring all those together and it'll overwrite where both of them, A and B, match each other. So you're going to get the best of both worlds. You're going to get everything that doesn't match on B, everything that doesn't match on A, and then wherever there are not duplicates, where they do match. So the question here can be, list all the names for South American countries that speak or don't speak Portuguese. Here's your table A. And then just include all other languages. So you're listing this language. It doesn't have a match on any South American countries, but here's a list of all the different languages that are spoken around the world. So you can see that, and then like what other languages are. Not the most insightful query, but it kind of tells you how the left and the right joins work. And then Portuguese already exists, so it wouldn't be in this list down below. So that's it for hour one. We're still on track just before 7 o'clock. So give everyone a 10-minute break. And during a 10-minute break, feel free to ask me questions about joins and let me clarify anything that I can clarify. So good time to take a break and digest. Go for 10 minutes, get a snack, get caffeinated. We're ready to keep rolling. Back in 10. I'll still be here, but everybody can be back in 10. This is definitely the part of the class where you've learned everything before, and now you're taking like everything, putting it all together. This one is probably, like for everyone out there, probably the most difficult class, I think, of the series. Yeah. Hey Douglas, I can't hear you. Are you're part of? Yeah, I can hear you now. Yeah. Ooh, echo. And Poem is here too. I'll grab you on attendance.
Hello? Jeremy?
Douglas,
Can you hear me?
can you hear me?
Yeah.
Okay, we're good.
Yep. A quick question. When I'm writing the code, do I keep stacking code on top of other code, or because I'm just deleting the code every time I run its function and I start new?
Oh, so are you're talking about like pasting examples in your code editor
Yeah,
and
do I
like
just keep stacking
keeping
it,
it
or
running? I guess it's up to you. You can keep all of them in there. Um, yeah, you can, and then you could just select the piece of code you want to run. Or oftentimes, I guess I just overwrite the code. I'm just like showing an example. So it's really just like personal preference. It might be
okay?
valuable to keep them, and then you can go back and run them later after class, or save something that you're doing, or play around with it later.
Okay, I was just
You can
wondering.
just stack it. You can stack them and save the file, and then you'd have it for later.
Okay, that works.
I know it's not this, like where you described the like the matching column between the two um, tables as the key, like on A dot P equals B dot P.
Mhm.
When you say key, is that what establishing the primary key was when we created the table last time?
Yeah, it can be a primary key or a foreign key. We'll learn more about foreign keys later. I kind of explained them in the last one where we it's more of a database design thing, but we'll explain that in the next lecture. But a key is either a primary or a foreign key, where those values are common to each other between tables.
So it does go with that key. It's not just using the word key.
Yeah,
I'm just trying to make the connections with all the syntax.
and in most majority of cases, it's a primary key between two tables, but not always.
Okay.
So, sorry, eating the Oreos. Um, then I better explain what a foreign key is. It'll be a key that's not the primary key of a table, but it matches the primary key of another table. So, um, could have customers from a bunch of different countries, and the customer ID would be the primary key on one. Country code would be a foreign key on it also, and then you connect to the primary key of the country code table. We'll see some of that as we the next class is in. Well, actually, the next class is in like cleaning and uh, case statements and working with text and stuff like that. So in two classes, at the end of next week, we'll work on database design, where you can see like the relationships between all the tables
Oh.
and how you design like a database with multiple tables that have relationships between each other. And not so much important as this class will be able to do it, but at least being familiar with it if you were to see it on the job and knowing what it tells you. Because these things can get difficult. Like I've seen on the job where um, IT will give you a schema of all the tables that are in a database, and they're literally like 150 tables with like thousands of lines between them. Well, and then you're like trying to trace through all of it and figure out all the relationships. And usually, IT or the development teams hate giving it to you because they know they haven't designed the back end very well. And that it opens up like a whole can of worms. But that's what data people do. They open up those can of worms. That's the questions they ask. So if you like causing chaos, well, what I say,
The person who asks all the questions, then they'll
opening up.
and then they get irritated. So it's like I will have found my niche.
If you like doing research and asking questions and providing answers that sometimes people don't like, working in data is for you. To me, it's more important to be truthful. It's important to be truthful. Now, if that's always appreciated, I don't know, but that's their job. That's the least you could do as an analyst. Sometimes a person you're giving the results to don't like the results, but they don't like the resulting data. But a different issue. And you have to explain it nicely to them or different terms. Or maybe the way you're bringing it together isn't what you'd expect. That happens as much as anything. That's where often the person asking for data, they aren't sure like what they need, so you bring it together, and then they're like, "Oh, that doesn't look right," or "We brought it together correctly or defined it correctly." I'll go into it some more, but talk about the difference between transactional data versus analytical data from this class too. That's often why the system doesn't define it the way you would for analysis. Did I give everyone a 10-minute break at 6:57? I'll give everyone another 5 minutes. Stretch. Start again here at 7:12. And one day, actually, I have a database behind my WordPress site that's hosted WordPress. And there's a database to track metrics.
Okay.
So eventually, once I build that, I can see customer traffic and like the different things that they do on the website. And then the WordPress add-ins, they work, record the information in the database. Which plugins? I haven't really got quite that far yet. I am using just ones for themes right now, I guess. But there are a bunch of them for tracking too. They're basic ones.
One time I'm working with, they wanted to track me.
It wanted to track what?
Like, traffic, it's like their company internet. But it's like, it's kind of hodgepodge together, and I'm like, I don't want to add a bunch more plugins because it's already like stretched, you know?
Yeah.
I don't like using plugins unless it's really functional stuff that is just a little bit beyond like the ramming of the I found like most of the ones I found that I thought would be good that you have to like have a Google Analytics account or this or this. I'm like, I'm not setting that up right now until they like know what they want to use. And the one I put in there, like, isn't really tracking. So like, I was just wondering what other use.
One that we'll want to put in is in the WordPress website is like a Google Analytics add-in to see who's actually converting from advertisements on Google. But not that too complicated now. I just need to get I need to get something out there.
So you would be looking for media like build like site side and media. I can connect to the plugin like kind of get those and although you just want something to build out.
Yeah.
Yeah, I could definitely do that. Do you have any designs or like with like branding requirements or things like that? It's just like
It's a
there's
startup.
content that needs to go on there.
Yeah.
Okay. And do they have like something current like I could look at for styling and stuff? Or no, nothing.
Oh, for the
Or no like
startup that I'm working for?
yeah, with the site it's like
Nothing. I'm
like a logo or anything?
choosing all of it. They do have a logo.
Okay. You know what color branding color?
Ish. Yeah.
Yeah, as long
Matching
as I
the
that, I
logo.
can kind of like, and if I know that it's really formal, it's really like modern, it's very like
Yeah.
romantic, whatever, like I can kind of like go with it.
No.
But if you're like, there's no information, build whatever you want, and I'll be like, I will build something that you were not thinking of, so you can give me some kind of parameter.
All right, we're gonna at 7:12. We're gonna go ahead and get started. Give everyone a minute to digest that last part that we were working on with joins. The rest of it's probably a little bit more straightforward as far as looking at unions, a little less conceptual, and then subqueries can be fairly conceptual, but we'll do some easy examples here first so you can really wrap your minds and heads around it, and then you can always make a query more complex. I always, when solving a problem or doing SQL, is that go ahead and share my lecture is I always break it down like something that's complicated in its simplest parts, which is just really understanding each table that's in the query and then putting it together one by one, or do a subquery first because you work from the inside out and then put the bigger query around that. And we'll see that in a second, but we'll go ahead and get started with hour 2, making sure everyone can see union and union all who's online. I think you should be able to. If not, just yell at me. I respond pretty well to that. But yeah, we'll go ahead and get started. So SQL union and union all. The purpose of the union operator is to append the result set or two or more select statements. So we've already talked about this before. They could actually do multiple queries, not just one or two. It could be 10 queries that you stack. You could do a query, union all, second query, union all, third query, union all, fourth query, and so forth. There's really no limit to it. So there are a few requirements to union and union alls. Is each select statement within a union must have the same number of columns. That's where the columns have to match each other. The columns must also have similar data types. So you can't mix integer decimals with character data types, even if they have the same name. So even if they aren't a perfect match, like one's a longer variable character type than the other, you can still append those two together. And I believe that it takes the longest type. And then the columns in each select statement must be in the same order. So if you have variable 1, variable 2, variable 3 in the first, it needs to be variable 1, variable 2 in the second, and then so forth. So the difference between union and union all, I already explained it earlier, but this is a more clear picture. It's a union. It includes everything from query 1 and 2, and then it overwrites duplicate records. So it only gets the duplicate records. It only keeps distinct records in between two. So that's like useful so you don't have a bunch of duplicate records in your data set. But union all could also be useful. This will include everything from query 1 and query 2, whether or not there are duplicates in the middle. This could be useful for just appending to, and sometimes having duplicates from this one, and then the second query will actually tell you something about the two data sets, and then including it together. So we'll do an example of this next. SQL, we're going to do a union all. This is a good example of what I was just talking about to see the United States being in both data sets. So the question is, list all countries in North America speak English and Spanish as a language with duplication. So this top query is going to be the language that's equal to English, and then the union all where the countries speak Spanish. So you can see the answer to both of those is United States, and that's in the second one also, first and second one. So it actually gives you information. If you did a union, it would just combine these matching results together. So it really depends on your question, whether you want to use union or union all, and what you're trying to do. What you're trying to do with the data, the resulting data. So we can go ahead and run this in my SQL workbench. Bring this over. This will be slide 13 with union all. So we have the first one is English. The second one is part of it Spanish, and continent is North America. So these are all North American countries. And it gives you that result that we had in the slide. The only challenging part here is that you union all of them. You're not entirely sure where the first query ends and the second one begins, but that's easily solved by running each piece of it. You can run each piece of it separately because they're really two queries that you're just appending to each other. All right. So union is the same thing. It's the same query, but now we're choosing union. List all of them with no duplication. And now you see the United States is only selected once, because now with the union, it combines duplicate records into a distinct record. So it's with no union is no duplication. Union all allows for duplication. So I won't run that in MySQL Workbench. It's basically the same query with union. It is the same query, but as a union instead. I'll leave that up to everybody to do, maybe coming up here in hour 3. Subquery. So these are also known as nested queries, inner queries. Sometimes inner select if it's included in the select statement. They must be enclosed by parentheses. So this is really key. So you have your inner query. This can be used in a where statement. It can be used in a from statement or a select statement. But no matter what your initial query, your subquery needs to be within quotes. So the subqueries can return a single value, row, column, or table. They can do any one of those 3. And they're evaluated inside out. So what this means is that the subquery is evaluated first, which would be this part in parentheses. And then the query, the main query, the parent query, is the outside part of it. So even imagine a case where inside of this you had another subquery. So this could be subquery within subquery or within subquery, and it always evaluates it from the inside out. So the very first query goes into the parent query, which goes into the other query. It can really get complicated, as you could imagine. Usually, like if I'm going to do subqueries, I like to put the subqueries in a view and then just call them like tables. Often, instead of like writing a query inside and figuring out what that does and then doing that, I like to write these as views and then just reference it as view. But you'll see this comes in useful in a lot of ways also. So example, just using it in a from clause. Remember the from clause is like you're selecting a table, except now we do a subquery inside of the from clause and return that result just like it was a table. So describing what this does is that this inside query is from world.country, and it takes the continent name and name of the country and population, and where the continent is Asia. So it'll take all of these countries in Asia and get the population. And that's from your friend statement. So it's using it like a table. Your outer query, what this does, it just is getting the continent, and then it's summing the population over all those countries and then grouping it by continent. And that's how you get to this final result. So you're using this query as a basis or a table for the outer query, which is summing it by continent, and then you're grouping by the continent, get that answer. So evaluating it from inside out for the subquery first, outside query second. So let's go ahead and run this really quick so you can visualize this. If nothing else from tonight, don't feel like if there's something you aren't sure about, don't feel discouraged by it. Now you know these things exist, and it just takes a little while to fully like conceptualize and know what it's doing. But now you have the knowledge and you know what you can do. You can go out and do more practice, and you're able to now start to put these things together. So I ran the inside query. So that's continent, name of the countries, and populations. Then if you run this whole thing with the outside query, it's just going to take continent, and then it's going to do a column function. You're going to sum over all the population, and then group by this continent Asia, because that's what you limited it to in the subquery to get the final result. And that's how a simple subquery in the from statement works. This is probably this type of subquery that I use the most often. Is if I want to derive a table really fast and then use it in an outside query or a result, I can do that. And then use it in an outer query to summarize it in some way. Like I said, oftentimes I'll put this query in a view and then just call it from a view, but there are times where writing the code in subquery is useful, especially in the from statement. So this showed how it worked. So it works from the inside out. So you can also do this in the select clause. So this is a case where we did a query and then we just returned a single value from this query. And then it's just duplicated. Since you do return a single value, that value is just duplicated across all of these. It's across all the records. So think of this as like dynamically getting the total value of that 44,892,707. That becomes that value, and then it just does it across all the records. But that's important because then you could say you get all the cases, the COVID cases, and now you can divide by that amount. And then you could say what states have the highest proportion of COVID cases. So that gives you information that you can use in your result set, often for other things. I don't use this one quite as much, but this is probably one of the best examples of it, is getting a single value and then using that across all of their records, or down all of their records. All right. And the one I use probably the second most is in the where clause. So this is where I'll often return a list. I'll do a query. They'll say select states from COVID-19 US states where the left state is equal to n. So we're using the left function to check the first number or the first letter in it, and if it's an n, we return that subquery. So remember, in a where statement, we can do an in multiple values. Writing a query from another table is really useful. So instead of having to enter Nebraska, Nevada, New Hampshire, New Jersey by hand, figuring out all the states that start with N and doing a list of those, you can do it dynamically with a query. So we'll get all of these values, and it'll do an outer query on US states where the state is equal to N, and then it'll get all the information about those and where date is. And then you can do a limiting condition on the outside. So where date is 2021, 10/15. So all the states of Nebraska from the United States table. I guess I think this is the date when it was updated, because those look like totals to me at the time. In many cases, the deaths there were. Yeah, total U.S. COVID cases is a 10/15/2021. Right. Ooh, we flew through it this hour. So class 4 review, we're already here. We did what I wanted to do, is give us plenty of time to work on these today. So class 4 review, we have SQL joins, combining the rows of two or more tables based on relational columns, related columns between them. Those are really columns that have the same data types and the same values. These are included inner joins, left joins, full outer joins. There were a couple that I didn't mention here. So this is like a full outer join where you exclude all of the nulls. So you do everything from A, everything to B, and then, well, this includes only the nulls. So where A is null and where B is null. So you can use the null keyword as a limiter or how you filter records on data sets. So this one's actually keeping all the nulls from A, all the nulls from B, and where they don't match. This one could actually be useful to find like issues in the data. What else do we have here? We have just your A's and left joining on B's, where they keeping all the records on A where they don't match and getting rid of all of them in B where they do. So this would be where there's not a match on A, where there's not a match on B, and so forth. So this is a really, if you're ever trying to refer to SQL joins and want to visualize it, this table is a really good way to do that. I didn't put unions in here, but unions are appending data with the same number of columns and the same data types. And then subqueries is a query that's nested in a select, insert, update, or delete statement, or inside another subquery. So we did all of these in select statements. You could also imagine it doing inserts. You could write a subquery and then a query, and then you can insert all those values. Because insert, you can do that with a select statement. Perhaps you want to do an update in your or delete, and in your where clause, like we saw, you do a subquery to get all those values dynamically. Also would be useful. So you can use subqueries in all these different types of outer or parent queries. Additional resources. So I put in two of these. These other two are from previous slides or lecture, but I found a good one on guided example from learnsql.com since we have some time. This one's really good. So this one will give you, like, start to get you familiar with the data set that they're using. So it gives you even a good introduction with relational databases, the information you often want is stored in several tables. Such scenarios, you'll need to join these tables. It gives you good information about the data set. It helps you start to picture and visualize it. This is like a book publisher, and they have books, authors, editors, and translators. And then you could even see like IDs. And Melinda, these would be these author IDs and editor and translator IDs. These would be like your foreign keys to other tables. So you have an author ID that matches the ID on the author table. And you have your editors, which matches the editor ID on the books table, and so forth. And then it gives you all sorts of examples, like showing books and their authors. And there's the resulting set. They describe how this code works. Showing books and their translators, and so forth. And doing left joins. So if you want extra practice and really read through it, I highly recommend this one. And of course, W3 Schools is just the best. They like reference even if you're doing other programming languages, I go to it for like simple code examples. I think it's great. You have JavaScript, Python, PHP, and data science libraries. But they have SQL joins, and then you have these down below, and they do the same thing. And where this is dynamic is that you can go try it yourself and do different things. So the data is already preloaded, and it's like a really friendly example. You can run SQL and get the result. So this is all about just this lecture is really just practice, 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 and then doing it on data. But like understand one of the things that'll help everybody on the journey the most, I think, is understanding the data. Just really understanding the tables and data that you're working with. Whether that's the first couple of classes that we did, especially probably class 2 when we're doing the homework and understanding the world schema, and then definitely with joins, it's like understanding what's in each table, what's in the common keys, and then how you want to bring the data together. It really helps you to start to formulate how to bring them together and what you want out of each query. So the more you can understand the data, the better, the more you're likely to be able to put together the query that you'd like to put together. The more it makes, and the more the code will start to make sense. All right, so that's actually it for tonight's lecture. I thought that was gonna take quite a bit longer, but it didn't, which is great. We'll have the rest of the time to work on exercises for this lecture. As you can see, for the exercises, I put together this schema to see how the tables are related together, how the keys are related, city, country, and country language from the world schema, and all of the columns in here. This will be common to see on the job, and this is called an entity relationship diagram. But the entities are your tables, and these are the relationships between the tables. And then you can start to put together all of these. I'll drop this example in Slack, so we have a chance to work through this. And then we have a homework for today that I'll help everybody get started on too. In this homework, since we didn't have homework for theory, we'll do one class 3. We'll do a combined class 3 and class 4 homework today that you can work on over the next few days in the weekend, and that we'll review on Monday. So I'm going to go ahead and end StreamYard. This is a lecture today on joining and merging data. Hope everybody found it useful, and we will continue next time with class 5, cleaning data using SQL.